On the dot.
All right. Thank you so much for joining us. My name is Chris Stanfield, and I'm here to present about the horror, magic, and science of toast. We're going to start off with the horror of toast. There isn't all that much horror of toast. But there is this.
Go on.
Okay, that's kind of horrible. Don't do that. So our challenge, the science part of toast, is how can we enjoy toast without this sort of thing happening? How can we have toast without burning our house down? How can we have toast without electrocuting ourselves? How can we have toast that is itself satisfying and not a thick line of smoke that calls the clown fireman to our house? The not chewing with your mouth open when you've got a whole bunch of jelly, we're just going to kind of leave that up to y'all. Toast seems to be as old as bread, and bread is actually one of the oldest preserved foods in the world. There's some question over whether bread or beer was the first way that people hit on to preserve food so that you could have meat outside of season. Now, the appeal of toast compared with regular bread is kind of twofold. What distinguishes toast from kind of mere bread? Anyone? Come on, people can answer this. I know it's early. Toast is brown, and toast is warm. So these are kind of the two key elements here. By heating it, we remove water from the toast, and this adds some crispness to it, as opposed to kind of the floppiness of regular bread. But the brownness is from caramelization of the sugars and starches in it, which changes the flavor slightly. So these are the two essential elements that we need to get from any sort of toasting process. The earliest toast was done with, can we go to the next slide? Toasting forks. There are toasting forks going all the way back to Roman times, and there is some reason to believe that there was toast even earlier than that. You would insert the toasting fork into the bread and just hold it directly over the fire. You also see a toast rack here. I don't seem to see a whole lot of toast racks in the United States. But you see them all over the place in the UK. I've actually got one that spells out toast from back to front, which is really classy. It adds a little literacy to the breakfast table, which I'm always up for. But later on, people began asking, is there some better way to do this? So I don't have to sit here dealing with this open flame, and I can still have toast. One of the first solutions to this was actually created here in India in the late 1800s, and it's these type of stovetop toasters, which, as it was pointed out, shows some kind of Dalak technology influence here. These basically sat on top of old-fashioned cast iron stoves, so the heat radiated up into it. It heats up the solid state element here. The toast sits 4 slices on here. You can see how there are these little wires on here. The wires actually hold it slightly away so that you can more easily pick it up and put it back on here. And then it's vented, which also helps control the heat. And this is effective. You can get your toast done this way. Can anybody see what some problems might be here? Why you might not really get ideal toast every single time?
One-sided.
Yes. It's one-sided. I must have heard somebody at home. But yeah, so first of all, you have to turn it over manually. And so then there's the question of how do you get it consistent on both sides if you're going to do that. Another problem is that you've got this heated element right here, right where your fingers are going to be. And that's a little bit of a problem too. And then there's kind of a third thing. We've got the electric revolution coming on. Shouldn't you have a separate electrical appliance that handles this? toaster there's a patent for. There's actually a period of toaster patent wars where people kept claiming all kinds of prior art, which makes it very, very difficult to sort out how many people were independently hitting on things in the toaster field and how many people were just engaging in toaster-related industrial espionage. But let's not sort that out. Let's just kind of look at how this works. If you look at the inside of this toaster, you will see that there are actually bare curly wires here. These actually heat up and turn red, showing that they're not very efficient conductors, which is on purpose because we want to actually convey that heat, convert the electrical energy into heat energy, and convey it to the toast. Now, we have the same problem that we had before, that we have to manually turn these over. It's been made a little bit safer. We have little bake-like handles on there, so that as you turn this, you will get your toast done on both sides. An alternate version of this from Sunbeam is a flat toaster that is a gravity-assisted toaster, which actually opens up. This will do 2 slices simultaneously, so they're done to the same extent. And again, if you walk up here, you can see that it has the same little curly wires in it. So again, we do have a little bit of manual problem, but at least we've made this a little bit safer in terms of testing our accuracy. You also have a type of toaster that's called the pinch toaster. And what's striking about this is this starts getting a little more efficient use of electricity. If you look inside of this, these are sheets of mica. It's a naturally occurring mineral. It splits into thin sheets. It's a poor conductor. It's a little bit translucent. You'll be able to see if you get up here. These are actually used in modern toasters. You can't usually see them because they're usually not exposed. Spring-loaded pincers clip your toast to the heating element. Once again, you're going to have to turn that over by hand. One problem with the pinch toaster is that it leaves marks on your bread. It compresses a little bit, and it doesn't toast perfectly evenly. And this is a problem in an era when people were expecting to see a whole lot of innovation. One solution that people got to this was these flip-side toasters. If you ever go to an antique store, you will find many, many varieties of these. I probably have 15 or 20, all different. Again, you can really clearly see the translucent mica in here. You can actually see through it, the wires wrap around it. This actually sets the toaster down so you don't have to reach as much into it. It brings it to you to just a little bit more. Again, it's only going so far. Can we go to the next? This brings us to this very, very important map. Charles Strite was an engineer who was unhappy with burnt toast. He was unhappy with reaching into the toaster. He felt that this was an appliance and it should be working for him. And what he needed to do was build a pop-up toaster. And he did build the first pop-up toaster. I don't have one of them here because they're kind of hard to get. His initial idea was that he would put a timer on it and that your toast would run for a certain amount of time and then it would pop up. Even though he had mechanical problems with it, he sold out his entire run. He spent quite a bit of time going to restaurants and repairing them. But that didn't actually destroy the market for them. What he found was that people appreciated the convenience of it, even though they weren't working very well at first. They could tell that this was a real and important innovation in toast. So there were some problems with the timers. Can anyone think what those might be? They might not be immediately obvious. What happens if you toast your first piece of bread, and then you put your second piece of bread in, and then you put a third piece of bread in, and you do a series of pieces of toast? Yeah, it'll get more and more burnt because your toaster is heating up from this lower temperature to a higher temperature. So the next innovation that we had, which I think is on the next slide, is called a bimetallic strip. And this is made of 2 different alloys. So as this heats up, it expands. So the next innovation in toasters was to have a bimetallic strip, which as the toaster heated up, would expand and hit a trip plate, thus triggering the pop-up mechanism. And this was really much better than the timer, because it was more sensitive to the internal environment of the toaster. There was one more innovation that we finally saw, but it took us until 1949 to get what's called color guard by Sunbeam. There are several variations on it. Have y'all ever seen a toaster, like a high-end toaster, that is labeled on one of the slots? If you're only using one slice, put it in the slot. Yeah? Anyone know what that is? Hint. It has something to do with what we're talking about. The reason for